Hi everyone. So thanks for the introduction, Mark, and thank you all for coming. Appreciate it. I sort of sent quite a lot of invites last week, sort of last minute sort of things. So thanks to everyone that can make it. And it's brilliant to see so many people here to deal with plastic pollution. My name's Joshua Doran. I think we've had enough of an introduction on myself. But I said I studied here 5 years ago, so it's fantastic to be back here. Presenting to all of you people. And like I said, we've got the power and position to do something in the organisations you're in. So and it's brilliant you're here today. So the purpose of this talk is to really set the scene for the day. It's sort of an introduction and kind of casting that nylon fishing net wide, if you will, that trying to encapsulate all those different routes, all the different pathways and sources, and kind of so set the scenes for the talks you're going to be hearing later on today. So firstly, we start off with some of those definitions and an S on the end there of what is plastic. Firstly, there's a lot of kind of contrasting views in the literature of different what microplastics are. So we'll kind of sort of set that standard. Then we'll look at the different sources. Falco's very nicely passed around this sheet here, so you can have a look at that on the talk as well, and it sort of goes hand in hand. Look at those reach and roots of plastic in the environment, and then also what does the future look like? And that's why we're here. Hopefully we can influence that future and change it, and then wrap it up with some conclusions. So starting off, firstly as well to mention, there are a lot of QR codes throughout the presentation, so do get your phones out, and if you want to take a deeper dive into some of that research and literature, it's worthwhile. So have a look. Starting off with those definitions, I'm sure, again, most of you are going to know a lot of the information from today, are sort of preaching to the choir, but there's a lot of sort of contrasting views in the literature on those definitions, but what we'll be sort of using today is the widely accepted international standard ISO 2020. So talking about megaplastics. Now, this is commonly anything larger than 1 meter in diameter. Now, that can be from, we went to the beach yesterday and there were polystyrene jetties floating around. It can be from discarded fishing nets, sort of these ghost nets that circulate around the oceans, sort of strangling any marine life that comes across it. So then we can move into microplastics. This is our day-to-day plastics that we're finding on the beaches. From your plastic bottles, frisbees, anything that we see. And it can be a range of polymer types from your PET, so plastic bottles, containers and such like. And we're coming into our microplastics, and obviously the hot topic really for today and everything that's going forwards at the moment. Coming in two different forms. First being primary microplastics, specifically manufactured to be a certain size, whether that's for beads and cosmetic products for exfoliating, that's for either sandblasting, even potentially bio beads used in wastewater treatment. And the main one and kind of the poster child almost of this is pre-production plastic pellets, otherwise known as nurdles, which again, I'm sure everyone is very aware of, using the feedstock for making all the plastics. These primary plastics do come with flakes and powders as well. And then we have secondary microplastics. Now, these are the result of breakdown of those larger macroplastics, forming regular angular shapes with a wide range of different polymer types within them. And this example here is one which washing up at about 3 kilometers of coastline in the northwest, and had actually no idea where it was coming from. And it's later determined that it was potentially from the recycling process of shredding these plastics, and unfortunately got discharged somewhere along the line. And then lastly is nanoplastics. Now, as sort of we mentioned yesterday in one of the lectures, this is sort of very much an emerging science, and there's little known about it at the moment. I'm sure we're going to be talking about that a lot more in the future. That's considered to be anything less than 1 micron, 1 micrometer, micrometer. And then those microplastics, that definition we're looking at is less than 5 millimeters in size. So sort of visible plastics, but still pretty small. So we started looking at those sources and where do they come from. So really good place to look at those sources, pathways and impacts is from one of our Goal 1 reports. This is a couple of years old now, so don't get me wrong, there's new literature out there, but do check that out. And it's something that we did with the Plastic Pollution Working Group. And if you want to take a deeper dive sort of into all of the stats around it. So this infographic here from, let's have a look where it's from. Yeah, so this was the Eunomia data published in 2016, and it's been widely referenced, but still very much relevant today. So when we look at macroplastics and those sources, like I said, we get the nets coming from shipping, but also just direct litter, unfortunately, from the leisure and shipping industry. Land-based sources of macroplastics are, well, basically we're looking at that input into the oceans as being over 70% coming from land, largely through our rivers. Looking at Plastics Europe data, where over 40% of that was thought to be from plastic waste, plastic packaging industry. So yeah, our wrappings and such like. And again, we know what those macroplastics are. We see that beach litter on our beaches, sadly, day to day. And this was literally yesterday. We popped out with Heather and Falco, and I thought I'd just add this one in here quickly. So this is just in Chesil Bay along the River Rich and up the road. And yeah, this is just a common sight with the different types of macro and also microplastics. You could pretty much find everything on that beach. And I thought I'd bring the life ring with me. I thought there must be a metaphor in there somewhere with something that was designed to save people's lives and has now become a waste and potentially impacting our lives now. So yeah, scary reality that this is just the norm. And we've got this shifting baseline where we can walk along our beach and just expect that there'd be plastic there, where in reality it should be far, far from our beaches. So looking at sources of microplastics, and there's another infographic here from the European Environment Agency showing all these different numerous sources of plastics into the oceans and just into our environment. So again, looking at those marine-based sources, that can be from the flaking of acrylic coatings on hulls and sort of anti-fouling paints. And of course, there's this chronic and acute loss from pellet spills. That's something we'll go in a bit more detail later on today, but I'm sure many of you are aware of kind of how large those incidents can be. From land, there is the secondary microplastics from the physical abrasion of tyres and road markings that enter our drains. Now, in the EU alone, approximately 500,000 tonnes of road tyre particles are released into the environment each year, as per in the UK from 2018. From our clothes, washing our clothes, it's thought about 700,000 microfiber fibers are released within every wash cycle. So over a year, it's thought that 87,000 tonnes are released, yeah, again in the UK into the environment each year from purely washing our clothes. Yeah, so and that was only in 2013. Otherwise, we've got cosmetic products, we've got artificial turf, we've got sports pitches, we've got again acrylic coatings and pellet loss on land, all entering our drainage, entering our rivers, and eventually finding their ways into the sea. But also, what we're finding is, especially with those microfibers from our clothing, they are entering our wastewater treatment facilities. Now, they actually become a very large sink for microplastics, which is a good thing. So we're almost collecting them there. But as I'm sure many of you know, there is a large amount of discharge of untreated sewage from our CSOs at the moment. So research in 2020 was identified that 94,000 microplastic particles per second were discharged into the River Thames downstream from Greenwich. And not only that, once that sewage has been treated, we use that sludge, and that's basically where all those microplastics are accumulating. And we spread that on our agricultural fields. So we're finding that there's a high density of microplastic fibers in our agricultural soils. So from a 2022 paper, there was 500 to 1,000 microplastic particles per metre squared in the UK. And you think then with the increase of runoff, again, into the rivers, we're just constantly moving these microplastics around every which way. So looking at how widespread is this contamination? So I really encourage people to, oh, Yannick, you're in the way. Encourage people to check out this link here with our world and data, which if you love graphs and charts like me, there is loads out there representing plastic pollution through the years. So this graph is illustrating from 1950s. This is where we sort of started to have a real mass production of plastic, sort of global production of plastics. And as we go through up into 2019, when it's so 2017 report, so estimates here on what 2019 would look like, we're going to over 450 million tons per year manufactured in production. So cumulatively, we're looking at 9.49 billion tons of plastic since the 1950s. And the likelihood is that that's still around today. So what we're finding is there's obviously a lot of plastic around. Now, there unfortunately is lost throughout that lifetime cycle of plastics. As soon as we pull it out the ground as crude oil, we're finding loss at every step. So that can be from those pellets, from the mismanagement of waste, and everything that we're producing. There is a huge amount entering the oceans. So again, more recent studies are looking at approximately 22 million tons of litter end up in the ocean each year. So that's equivalent to around 60,000 tons a day entering the oceans. So we're talking about vast quantities, given how light plastic is, and yeah, the tonnage of that, it's quite daunting, really. So this is where there's this need to try and assess potentially circular economies with the plastics that we do have in our lives. How can we reuse these? How can we, as opposed to it being a waste product, we can be using it again and minimize our needs to be ripping oils out the ground to make new virgin product. And there is talk later today from the University of Portsmouth and looking at how we can potentially use enzymes for that waste management when things can't be reused from that side of things. So I'm sure it's no surprise that the rivers are one of our largest sources of that land-based pollution into our rivers. So again, Goal 10 report, really encourage anyone to look at that if you're sort of curious on what the sources are. Well, those sources, how we can control them. So there's loads of different examples of that. But one of them here, and sort of one of the most extreme examples, is in Guatemala. So the non-profit organization Ocean Cleanup, which I'm sure many of you are aware of, basically have identified that this river alone is responsible for 2% of the world's global sort of emissions into the oceans. And what this is from the 8th of April this year, so very relevant. And what there is basically there, it's the Guatemala City landfill that's upstream from here. And also there's a large amount of illegal waste disposal, all flying down this river. And it's over an hour period that they've recorded this, all using the interception barge. And you can see for a scale, just in the top where the timer is, and there's people there on the platform. That's kind of how much we're looking at, and that keeps going. I think we've got another few minutes of that. So the benefit of this, however, is that we can stop it. So we can look at the idea that if there's potentially 70% entering from our lands and rivers, well, we can basically be putting in systems like this to try and stop that getting into the oceans to start off with. So yeah, it's pretty scary when you see that starting to build up, and they're continuing. They're literally, you've just got diggers and lorries on the constant turnaround removing this material. So let's see how far it goes. So if I cut towards the end, you can see it just completely piling up. That platform at the top now is almost covered. And yeah. Sorry? Oh yeah, you'd think so. Yeah, that's circular economy, isn't it? You know. So yeah, so there we go.
Is there any analysis which markets those plastics are coming from? It's not going to be quite a while, is it?
I don't know, to be fair. It's something that's worth looking into. And yeah, again, Ocean Cleanup, they've got a lot of work, and they're doing a lot of obviously trying to prevention as well. So hopefully that's being addressed. I mean, that's the main thing, obviously. You know, yes, we're all spill responders, but if we can prevent it in the first place, that's route one, really. And that's what we're kind of aspiring to. So with Heather and the team at Fidra, let's move Yannick again. So yeah, we did some work last year on mapping the global plastic pellet supply chain. So really encourage everyone to look at that. And there's some fantastic resources to download, infographics, case studies, and all those sort of things that you can find on this. So a couple of the slides that I'll be going through from here on in are referencing back to that data that we identified last year. So in 2021, a total of 123 countries imported plastics in the primary form. That's 73% 3% of all countries, and 123 countries exported it in its primary form. So as you can probably tell by now, this is a global issue, and it is far-reaching from even just the side of pellets, let alone those macroplastics. So coming a little bit closer to home, looking here in Europe, 15% of the world's plastic production was produced here in 2021, employing more than 1.5 million people in the industry. We've got 4 of the world's top 10 exporters of primary plastics and 5 of the world's top 10 importers. And this image here is basically highlighting in red plastic industry that's registered as sort of dealing with plastics. We've got sort of those large ports, and then also positive nodal hunt data as well. And we can start to piece together some of those correlations where we're finding a large amount of pellets and a high density of industry. And then taking an even closer step to just down the road and along the south coast. So this was a screenshot I took on Sunday of recorded sort of pellets, along the southern region. So green identifying that no pellets were found during the survey, which I can probably count maybe 10 there. And then looking at the darker colours where we're finding high density of pellets and huge concentrations right on the doorstep here in Southampton. So again, I would really encourage people to, I'm going to move you over here. So do check out sort of the nodal hunt data and look on your local beaches at home. See, are there any recorded pellets there? Look at your favourite beach in Greece or Spain, and if there aren't any reports, go out there and do a nodal hunt. See if there's anything there. The more we build that data, the better. So yeah, encourage people to go check that out. And Heather will be speaking later today as well on sort of the role of citizen science and NGOs. So yeah, worth checking that one out. So using that data and that Eunomia data, I extrapolated that with what was estimated pellet loss in Europe, and what we were able to kind of get a rough estimation of a kind of upper estimate. We could be losing up to 22.4 trillion tons of pellets into the environment each year at current status. Obviously, that's a very large number, and it's kind of hard to compute what that really looks like. So with a pellet's average size being about 3 millimeters in diameter, therefore that upper estimate could be up to 22,000 football pitches a year entering in the environment. So talking about sort of vast numbers on that side of things. So again, how can we prevent that? And Falco after this will be talking about those sort of policy changes that hopefully will be coming in and what's happening at the moment to stop this being hopefully a reality. Oh no, that's not what I want to do. Sorry, Yannick. So we know that the US are large exporters, and we know that Europe are large importers. I can minimize him, perfect. And he's gone. Nice one, cheers. Cool, thank you. So we know that there's this main shipping route, these lentil-sized plastics on a daily basis going back and forth, having several stops along the way. In Le Havre, Antwerp, Rotterdam, so we've got Charleston, the Gulf of Mexico. We all know have got serious issues with pellets, and then we look at this map and you think, I wonder why. So we know that along this route there is either chronic, there are acute losses that are occurring on a daily basis, whether they're not being reported. It's the sort of transparency is one of the biggest parts of the research we're finding, that to get some of this data is so hard to find, and it's just not out there. So everything that we're finding is likely or potentially an underestimate of what the sort of true scale and true picture is. Again, another prime example of one of those shipping routes is from China across to Saudi Arabia, and we're looking at sort of those large ports. As you can see here, we've got a route that crosses sort of many nations. And in 2021, 750,000, I think 750,000 tons of just one polymer type transported along this route in a year. And on that, we've got 4 acute losses that have happened since 2012. So that's Hong Kong, yeah, in 2012 there. In 2021, big Sri Lanka spill, which I'm sure many people know about, where 1,680 tons of pellets were lost on the coastlines of Sri Lanka, leaving dense layers of this all on the shorelines, which members of the UK and Iron Spill Association attended. And then last year, we had plastic bags just washing up on the beaches of Dubai and Mumbai as well. So yeah, it's a scary reality that there are nations, so the ones we've highlighted here in pink, a large percentage of their GDP comes from tourism. Now, these nations aren't the big players in the plastic industry. They may be producing some, but they're the ones that are at risk. They're the ones that are going to be in, their environments are going to be impacted, and the social and economic consequence from these other nations, yeah, potentially causing those issues. So I'm sure you've seen lots of photos of this. This is from that Hong Kong example in 2012. And yeah, you can imagine this on any sort of beach. There were 6 containers lost overboard from a storm event that we can see sort of bags washing up a container there. And then once those bags split, billions upon billions of pellets being spread across the coastline. I can't remember sort of too in depth, and if you look at one of those case studies, it sort of shows you sort of more the stats, but there was on islands upon islands, they were finding these pellets over years to come. And this is almost copy and paste of what happened in Spain, in the sense that there was a loss of containers hitting onto the coastline, and they're still identifying pellets even now. With climate change on the horizon and storm events likely to increase, we're potentially going to be seeing more incidents like this occurring. So how we can better protect these containers going overboard is key. But these losses can occur as well inland from rail derailments in the US, which is a common sight, and sort of you get Google alerts for nurdles and pellet spills, and that's getting them at least once a week of sort of these sort of things happening. And also in France on road traffic accidents as well. So in France it's going quite well. There's quite a lot of need for reporting, and once those things occur, they are getting identified. But also these acute spills are occurring and people aren't aware of them. They're not being published. So yeah, we need to basically have better transparency in the industry of kind of stop these sort of things happening. And then as well, this is chronic pollution. So these are all of those red dots that you're seeing wherever there is plastic manufacturers and converter sites where there are pellets being lost just from these bags sitting outside. And this is a photo from Surface Against Sewage back in 2020, I want to say, literally just down the road of a site which has pellets outside, got forklifts going all around the place, lifting these things and moving them around. And there's just losses entering the drains, the wind transport blowing them around, and then ending up on the shorelines in SSS size and local nature reserves, where there's wading birds and everything trying to find a meal amongst all of that. It's covering vegetation and just not letting things to thrive at all. So it's a scary reality that is happening everywhere at the moment, and hopefully we can look at addressing it. So what does that future look like? And don't worry, there is a bit of light at the end of the tunnel. So using that data of what we sort of look at pellet loss and trying to put that through into the future on same level of production and same level of loss, we could be looking at a cumulative total of 4.5 million tons by 2030. That's 22.5 trillion pellets. So we're potentially somewhere along that projection already. Now, as we know, there is a large amount of sort of literature out there looking at the expected increase in plastic production. So again, using that data from our world in data. So by 2040, plastic production could be up to 765 million tons. And then in 2060, 1.23 billion tons. If we don't change, if this business as usual scenario continues with our reliance and dependence on plastic, this is the future we could be looking into. People get that. So these two graphs here are a really interesting one to look at that in more detail of the microplastics on the surface oceans and macro and micro. So from 2019, we've highlighted here that if emissions were to stop in 2020, we could actually be seeing a decrease in macroplastics on the surface. If we continue as we are, yeah, we're going to be continuing to see an increase. But if emissions grow, which potentially is what we are looking at, be seeing that sort of exponential curve. But the point being is that even if we address our macro, we're still going to have a huge microplastic problem because of that degradation of those macroplastics going forwards. So lastly, wrapping up with some conclusions from there on in, and said people, all the talks really from the rest of today will give you a bit more detail on all those sort of elements. But as we know, plastics are throughout our lives and they're invasive in our environment, within our bodies. I don't know if anyone saw the recent report about plastics being identified in all manner of organs in our bodies, which was no surprise that we're drinking out of plastic bottles, where our water supply comes from plastic pipes, and there's all these sort of things. So we know it's invasive and it can come from several routes to get into us and all those sort of areas. But we've got to understand that it's our future, that it's impacting, and like I said from the start, we're the people in the room that can have an influence. You wouldn't be here today if you didn't want to address plastic pollution, and within your own spheres of influence, within your friends, family, and that next generation, be the change you want to see. And yeah, I said, hopefully we can make a difference. So just quickly draw your attention to a little plug for later on this evening at about 6:30. There'll be a talk from the RGS with sort of a panel of people in the room today. But looking at those solutions from that top-down approach, right from the grassroots bottom up. So what sort of things can you do in your personal life to hopefully stop plastics and pollution? So do give that a scan. If you're able to attend, it's free to register. And yeah, it should be good sort of discussion with everyone in the room.
I think we're here.
Yeah, we're in here. So literally, so it's just getting another coffee and yeah, it's a long day. So yeah, great. Thanks for that. Like I said, whistle stop tour really, and trying to just be an introduction for all the other talks you're going to have today. So yeah, and obviously a lot of this work, without Mark and John in particular as well, yeah, wouldn't be possible. So thank you all, and yeah, hope you enjoy the rest of the day.
Question. I had a very interesting chat when I met Richard and Katsia, who both work here, about the mass of plastics in the ocean. Richard, did I get it wrong? But you have an estimate of the mass of plastics in the ocean, don't you? You believe we underestimate what's in the ocean?
Yes, well, the traditional estimates are about 10 million tonnes per year, and some work that we did was, without paying too much on about our own work, but basically we asked a very simple question. If we know how much is going into the ocean, if we measure how much is there now, then we can calculate how long does it last. And I said, well, even with my poor mathematics, I thought I can do that sum. What we found is that the amount in the ocean was more than we've ever put in. Right, so those of you who've got an understanding of this sort of maths, you can't do the sum. So all you know is that 10 million tonnes going into the ocean is wrong. It may be double that, maybe 5 times that, maybe 10 times that. All we know is that is wrong and a gross underestimate.
Great. You said exactly what I hope you'd say. So that scares us all shitless, doesn't it, really? Right, okay.